Some quadratic equations have no real answers. Instead, their answers are imaginary. And so with our understanding of complex numbers and imaginary numbers, and that square root of -1 being represented by I, it gives us a vehicle to be able to solve these types of questions. So for the examples that we have in front of us, we're going to solve all of them using square roots. As we look, there's no x term in any of the equations, so that means I can just isolate the x squared and then take the square root of both sides. So that's going to be what I'm going to do on this first one. I'm going to start off by subtracting 27 from both sides. So I get 3x squared equals -27. So now I'm going to divide both sides by 3. I want to isolate that x squared completely before taking the square root of both sides. So I get x squared equals -9. And now at this point I'm ready to take the square root of both sides. So if we do that, I get x squared equals, now I still need to include my plus or minus like we did in the other equations we solved via square roots. But now I have this square root of -9. Now I have to separate out the -1, the root -1, just like we did when we were simplifying these square root expressions on their own. So I'm going to have, whoops, it's no longer x squared, my apologies there. So we're going to have x equals, so plus or minus square root of 9 times the square root of -1. And then of course, we've got to simplify one last step. So I've got plus or minus square root of 9. We can take that square root, it's just 3. And then the root -1 is going to be changed to I. So our answer is plus or minus, we can clean that up a little bit, 3I. So we've got two answers, just like we almost always get on these x squared problems. It's just in this case, they both happen to be imaginary. In the second example, I've got the same idea. So I'm going to subtract 9 from both sides. So I've got x squared equals -27 minus 9 gives me -36. And so now we're ready to take the square root of both sides. So I've got x equals, and then of course plus or minus, and then I still have this square root of -36. So I have to separate the root -1, so I've got x equals plus or minus root 36 times root -1, and then very similar to the last one, we've got x equals plus or minus the square root of 36 is 6, and then the root -1 gets rewritten as just I. So plus or minus 6I. For the last one, so same idea. I'm going to add 1 to both sides. So I get 1/3 x squared equals -6 plus 1 is going to give me, or -7 plus 1 is going to give me -6. Now I'm going to get rid of that 1/3 by multiplying both sides. So instead of dividing by 1/3, we can multiply by the reciprocal. So the 3 and the 1/3 cancel out. We're left with x squared equals, and then over here we've got -18. So we're ready to take the square root of both sides. So we get x equals, and so once more, plus or minus, and then I've got the square root of -18. Have to separate out that root -1. So I've got x equals plus or minus square root of 18 times the square root of -1. Now in this one, we didn't end up with a perfect square for the real part of it, so I'm going to have to do my little factor treeing here. So if I go 9 and 2, 9 is a perfect square, so I can take the square root of that, but then the 2 will be trapped. So in the end, we get x equals plus or minus square root of 9 is 3, the 2 is trapped, and then again, we don't want to forget that root -1 turns into an I, but we have to make sure that it's not underneath the square root symbol, it's representing the square root of -1. So just need to be careful about how we write our answer, but there we've got it.